So the next speaker we have comes back to the topic of MetaPost and Metafont for creating fonts. It's Rajeesh KV from India, and he will present a complex typeface, and as you can imagine, it's not a Latin one, but an Indic script. Okay, thank you.
Right. I'm here presenting about a complex script typeface that we developed recently in collaboration with two of my co-authors. So I'm presenting this on behalf of them, and in the spirit of better. Okay. So, in the spirit of Ben Davis, I reserve the right to redirect questions to more appropriate persons. And we collaborate on an open source organization which develops typefaces, fonts for our language and script called Malayalam. It's spoken only by 35 million people, I suppose, but the useful number of fonts typically maybe a dozen fonts. That's one of the reasons that we develop and open source it. Okay. Let me figure out. Is it the left one or
I think one? It's to the left. Yeah.
Yeah. I did press it. This one. Okay. Thanks. Right. I'll give a brief overview about the script, Malayalam script itself, used to write both Malayalam as well as Sanskrit text, which has a lot of interesting properties. First thing is that it evolved through Brahmi and then the Grantha script, which is prevalent in the South Asia. A lot of scripts follow or evolved from Grantha script. And almost 120 characters are already encoded in Unicode, which are the base character set, so to speak. But that's not the entire character set in the script, because we have the ligating properties. Consonants may join together, and the vowel signs again join with the base character, whether it's a single character or multiple characters. These do not need to be encoded separately in the Unicode, because they form from a sequence of already encoded basic characters. That also means that when certain characters are together, they form a completely different shape, which means we need support of complex text shaping from the software, like Harfbus in Linux operating system and even browsers, or DirectWrite in Windows, or Cortex in Mac. Right. I'll show you some examples of the complications. So the first one is the syllable crew. I've also written the Latin or Romanization on the left side, so you can have an appreciation of it. You can see that ka, ra and the u vowel symbol join together into a single glyph in the font. Now this follows something called the traditional orthography, which was written in the past and evolved over centuries. But in 1971, there was an effort to minimize the number of characters in the script, and it's called the reformed script. Now almost all the commercial fonts follow this simplified character set, but we want to follow the traditional character set, preserving the entire character set used in the past, so that we can represent those documents faithfully. In addition to that, these are much more aesthetic, and we prefer that. Now the vowel signs are part of another complex story, because even a single vowel, the u vowel, has 4 different forms depending on the character it conjoins to. I'll show you some examples. First one is ku itself. That takes a small shape at the right end. And another one is chu, where the vowel symbol goes beneath the base character. And the next one is thu, which forms like a sitting a chair, and another one is new. The aspirated version of it, the oo vowel symbol, again has 4 different shapes like this one. Right. Naturally, this requires complex text shaping support, which is thanks to Harf Bus. It's now in CTech, UiTech, in browsers, graphical toolkits like GTK or Qt, and even in browsers like Chrome and Edge. Right. So now, in the past, we have released a number of fonts which were all designed either using FontForge or FontLab and graphical design softwares such as those. So why did we want to go to Metafont and MetaPost? A couple of reasons. First one is, of course, we wanted to learn Metafont. The second is only a few of us are really designers. Most of us have some programming background alone, and in that sense, Metafont is a natural fit. So we decided to go ahead with Metafont, and the first challenge was to learn Metafont. So we referred the Metafont book and started learning it. And it also, later on we realized that it brings a number of advantages. First thing is that we could reuse the components of a shape itself because they are code fragments. The second thing is that because Metafont enables us parametric font design, we can have an entire family of the typeface from a single source, such as the thin, regular, bold, semi-bold, even slanted versions from a single source. And very fine adjustments to the glyph shapes and curvatures are much easier because it's just some values that you can adjust rather than trying to adjust in the graphical software tools. Plus, the source is plain text, which means that we can have distributed and collaborated development, and we use Git for the version tracking. And we also found MetaPost as a superset of Metafont that gives us a lot more additional functionality, plus ability to produce vector graphics, because ultimately we wanted to produce OpenType fonts or outline font formats. So MetaPost gives us that for free, and we generate SVG for each glyph. Right. So the first thing, or the first part of the research was to identify different components of the glyphs that frequently occur, so that we could design them first and then use those to assemble into a specific character or a glyph. This uses the reference font called Rachana, which has been developed in the late 90s, and K.H. Hussain, who was the original author, also did this research work in identifying different components of a glyph. So an example, I'll show you 2 or 3 examples. An example here is the character, the right part of the character, which repeats in a number of glyphs. Another example is R, that repeats, the right side repeats in a number of what is called as chiller characters in Malayalam. These are like pure consonants without the inherent vowel sign. And another example is the left side of the consonant ta, that is repeated in a number of glyphs. Now, this is not an exhaustive list, of course. And an astute reader could immediately see that the Chilu letter il, that is the second character on the second row, is a combination of the third component and the second component. And nearly 100 more components were identified, but I don't think we had to use that much because many of those components occurred in 1 or 2 characters, so we just defined them along with the character. So they were not reusable, so we didn't develop them that much. Now I'm going to show you how we use it, and apologies for the very small labels. I realized the mistake, of course, only after submitting the slides, which was noticed by both Barbara and Carlberry. So we're going to create a letter called na, which I have shown you earlier, which has two components, the left component and the right component. These components are developed as macros and put into a single file called the ml_shape_lib, and we import that in when you want to define a new character. And each character is defined into a separate file so that we could generate individual SVGs for the characters. So you input the library, and you of course say the begin fig and an identifier, and the characters or the shapes are defined using the coordinates that you have to specify. And then we use pen stroke. Before using pen stroke, you have to specify the width and angle of the pen, which is again defined in the macro p stroke, which defines sets the stroke width and the angle of the pen, and then does the pen stroke connecting the coordinates which were defined earlier. So you will get a component like this, and you define the next coordinates and the p stroke corresponding to it, but you want to shift this character after, or this component after the first component. So there are multiple approaches how this can be used, because Metafont already has the shifted transformation, but we opted for a simpler x shift and y shift in the macro definition itself, where you can dynamically specify, okay, move it after the coordinate x coordinate of 1f, which is basically the last points in the left glyph, and then you start it from there, and also adjust the width so that the curves are joined smoothly. Now sometimes you define an entire glyph using different components, and we have encountered situations where you want to alter certain parts of the glyphs or move certain coordinates by a certain amount of, let's say certain amount. And here is an example of the character the. You can see the coordinate and the pen stroke defined. And let's say I want to move the point 1b, which is the second point starting from the left, even further left, and I uncomment that commented line dx1b by a -2 units, and it moves the specific coordinate to the left, and the curve or the shape is altered. Now this is taken care in the coordinate g, the macro itself. So if there is a dx defined for that particular point, then it takes into consideration, and when we do the pen stroke, it's already taken care. Now another example is sometimes you want to change the angle or width at specific points of an already defined shape. So in this case, I would like to increase the width of 1D, which is the right point, second point from the top, and 1H. So I can simply say width of 1D equal to width of 1H equal to width east plus 1T. So that's an already defined variable plus a T, a minor epsilon unit. I can also change the angle only by setting angle 1A equal to the angle on southwest, which is the first point. So these minor adjustments, even after the components are defined, when we actually define the glyph, the character is possible. Now another example I want to show is stacked conjuncts. These are double conjuncts. It's pronounced as uppa, as in kappa. So the same glyph of pa repeats itself, and that's fairly easy to do in MetaPost, because you take the glyph definition glpia and put it in an image, save it, then you have g2, again glpia, but this time with a different prefix, because they both use the same coordinates and we want to distinguish between them. And then scale it down by say 60% and set the current picture to the first path, add the second picture to it, shifting it further down and align it to the right side, which is obtained using the X part of the left lower right corner of the top glyph and with the upper right corner of the lower glyph. There are a couple of booleans that I didn't explain, which I will come to, especially the V conjunct. The reason is, if you compare these glyphs on the left and right, they are nearly the same, but the pa on the below, its stroke width is also proportionally reduced, which is not desirable. We would like the stroke width to remain similar with as the top one, and the only way we were able to achieve that is to magnify it a bit further by setting this boolean. So that in the glyph definition, if we say that okay, this boolean is set, we multiply it by a certain scale factor. Okay. Now another interesting part is when we have to join a curve with a straight line or a square, and if we just try to adjust those 2 points together, either the stem protrudes to the left or the curve protrudes and the curvature is not seamless there. What we could do is that we define a macro which uses simply the field row, dynamically calculating the lower left, upper left, lower right and upper right, draws from those lower left to upper left and then to the upper right, lower right, and then cycles. Sometimes we also want to reuse certain glyphs once they have defined, so that the character here is ta, the first one, and the third one right beneath it is basically pronounced as tr, and you want to attach the r vowel sign to let's say the half of ta. What we could do is that we use the sub path from Metafont, where you say okay, just draw the coordinates are already defined from bottom left to right, but you instruct Metafont okay, but draw it only from this point to until that point, and then you can attach the next component by adjusting the x and y coordinates and also setting the width accordingly. So these are all possible, and the curve is smooth, no disconnect in between them with these adjustments. So it's quite flexible, but of course it comes with its own disadvantages as well. Okay. Now I want to go back to the vowel signs one more time, which has these 4 different formats, but we wanted to use a single macro definition, if at all possible, a uniform macro definition, and reuse this, and we have succeeded to a certain extent. For example, this syllable pronounced as pu, pa, with the u vowel sign attached beneath it. One of the challenges was that the below curve incises into the horizontal stem, and we would like to remove that overlapping part. Unfilled doesn't work because the resulting outline or the SVG is not proper, so that we could easily import it in FontForge or other vector graphics tools. We had to use the overlap removal, and thankfully from the Polish tech team, we MetaType, there was a macro which returns the path where the overlap is removed, which is called the find outlines. So you take the path of the horizontal stem and the path of the circular vowel sign, and then you pass both paths into it, and then use fill draw finally to draw it, so that there is no overlap. All right. Now, once we have the characters designed or defined using Metafont, compile each one using Makefile, of course, into a target directory. So all the SVG files are there with the specific glyph name that we want in the character set. We don't use the Unicode character font names or the Adobe glyph list names for different reasons. First one is that once the glyphs are drawn, which is not sufficient, unlike Latin characters, you need the complex text shaping support, which has to be enabled or built into the font using OpenType rules. And we use Adobe feature file to write this comprehensive script because we have nearly 1,000 characters, 900 plus for sure, and in Malayalam script itself, plus Latin characters and numbers would be nearly or more than 1,000 characters. So we use we made use of font force to produce the final OpenType fonts, whether OTF, TTF, or the web fonts, WOF2 format in the past, and we wanted to use the same, but of course has to adapt it. And fortunately, Khalid Hosni has already developed an OpenType version of Punk font by Tonnuth called Punk Nova, and there was a build script that Khalid has developed, and I see that Linus Romer also has developed the MF2 outline, and I was evaluating it when he mentioned. But we went ahead with Khalid's script, but we had to add a lot more functionality. And we also wanted to make this configurable, so the font metadata and certain features like the adjusting the left bearing of characters or the right bearing had to be configurable. I was brainstorming with Linus earlier, and he mentioned that maybe a comment in the generated SVG file might benefit, which is a possible option. But what we have opted currently is to have a simpler INI format configuration file where you specify the Metafont metadata, such as the font family name, the version, copyright, information, license, and the default ascent and descent values, which are important because when FontForge imports the glyphs or the SVG files into the glyph slot, you have to have a defined typically 1,000 pixels by 1,000 view box. And on the lower left, you could see other, you could specify other definitions, parameters such as where to find the SVG characters, the directory to pick these SVG files, and the Adobe feature file. And since we are not using the Unicode glyph names, we also need a way to specify the Unicode code point for this basic character set, which is again defined in a text file, a map file. It's simply the glyph name equal to the Unicode code point format. There is also an option to scale the glyphs automatically when FontForge imports it. Sometimes it's needed, sometimes it's not, because if the view box of all the characters are 1,000 by 1,000, you don't need to scale it, but otherwise you may need it. That can be set to true or false. And some characters which you don't design, such as space, need to be present in the font, otherwise you get a long string of characters in a sentence. So you need a way to specify the width of that character, which could be specified under the width. And as I mentioned, very often we have characters that needs to move closer to the right side of the preceding character. Kerning wouldn't work because by default this has to apply to all the preceding characters. So we want to set by default the left bearing itself, which can be set. Negative left bearing can be set for the specific glyph names. So on the left side you have the glyph name equal to then a pair of the left and the right bearing. Okay, I think I have covered the important topics. Now this is just a tip of the iceberg. As mentioned, we have 900 plus characters and a lot more challenges. A lot more detail is available in the preprint, so if anybody have any feedback or suggestions for improvement, I'm all ears. Okay, the entire code is open source and it's available in GitLab, including the Metafont, MetaPost sources, makefiles, shaping rules, Unicode mapping, it's all in there. And of course, we would like to acknowledge first of all the Metafont book, which gave a lot of insight into how to use this and quickly build aesthetically pleasing fonts. A lot of input and ideas we got from MetaType 1, and of course the find outlines macro has been very useful. And in 1991, Jeroen Hellingman already developed a typeface, Malayalam typeface in Metafont, but I think it's a reformed script, not the comprehensive script, and we also referred to his documentation while learning it. And of course, Khaled Hosni for licensing his build script, open licensing, and allowing us to reuse parts of it. If you have any feedback, I would love to hear it. And with that, I'm open to questions.
Okay, thank you very much for your talk. Are there any questions? There is one.
I thought that would be a record.
Are you planning further to develop other Indic scripts?
We focus on Malayalam typeface primarily, but a lot of this is of course reusable in other Indic typeface. And yes, the immediate plan is to develop a font for Tamil, which is a close relative of Malayalam, but with a much larger speaking community. But it's much simpler because they don't have 900 complex characters. They have only very few limited sets. But yes, we plan, in the immediate future, we plan to develop a Tamil typeface also.
You mentioned that you looked into MetaType 1 to some degree. Have you considered using MetaType 1 directly instead of going through SVG files?
I wasn't sure that it outputs SVG files directly, so that's one of the reasons. I wasn't sure that MetaType 1 directly outputs SVG.
It doesn't.
Does it?
No, but you can basically directly generate the font outlines with it.
Okay, so I wasn't aware of that.
Okay, any more questions? If this is not the case. So thank you very much again for your talk.
Thank you.